So now we discuss properties which are also called the results of operations on sets. So we already discussed operations. We have discussed this 4 operations: union, intersection, difference, and complement. These 4 operations we have discussed. Now we see some standard results. So for any three sets, let me call A, B, and C with universal set capital U. That means this is the largest set for given 3 sets A, B, and C. So following our standard results, always true. So first one there, that is if you find A union A, and if you find A intersection A, that is union of set with itself, intersection of set with itself, which is again A here, again A here. This is called idempotent properties or laws, which is quite obvious, you can verify. The next one, I'll find A union B and B union A. So I'm just changing the order. So you can see that these two are always equal. It's like our addition. If you find 1 plus 2 and 2 plus 1, these two are always equal. 1 into 2, 2 into 1. These are always equal. So same way for union operation. If you find A intersection B, B intersection A are always equal. So this is called commutative property. Commutative properties or commutative laws. That means order is not important for union and intersection. Whether you find A union B or B union A intersection B or B intersection A are always equal. The third important property, which is called associative laws. That's for 3 sets. I'll find A intersection B intersection C. So I'll get this first and then this. Here I'll find B intersection C first, intersection A. These two are always equal. What you did on the LHS? You get this first and then this. Here you get this first and then this. Bracket should be operated first. And similarly for union, A union B union C equals to A union B union C. These two are called associativity. These are also true if you recall for addition. 1 plus 2 plus 3. It is always equals to 1 plus 2 plus 3. Similarly for multiplication also even. The fourth one, which is again very important, which are called distributive properties or distributive laws. So here we have A intersection B union C and A union B intersection C. What you did, you just interchange the operations. A intersection, inside the bracket, union. So outside and inside you have different operations. Here union and intersection. These operations are different. Then these two properties says that you can open the bracket. So A intersection B, one bracket, then this union, and A intersection C, that is in the other bracket. Your brackets are important. I repeat, A intersection B union A intersection C. Or if you look at the other way around, you can take this much common, so we'll get this. Same way here, A union B, this much, intersection A union C. A union B intersection A union C. So these are the two important properties which are called distributive. Intersection over union, union over intersection. Always true for any three sets. The next one is if A is a subset of B, that means A is a smaller set and B is a bigger set, like this. This is set A, this is set B. Every member of A is in B. Then, if you find their intersection, A intersection B, so common in these two, so common will be obviously A. So intersection B is A. And second one, A union B. Union means you combine members of these two. So if I combine members of these two, I'll get the bigger set, that is B. So this is again very important property. If A is a subset of B, then intersection is a smaller set and union is a bigger set. For example, if I find n intersection z, n means all natural numbers and z means all integers, so it will be n. And second one, if I take this n union z, so here this is smaller set, this is bigger set, so answer will be z. Why this? You know this because n is a subset of z. This is always true. Okay. Now based on this, the next property, you recall definition of intersection. So if I show in the Venn diagram, if these are the two sets A and B, so intersection of is this is called a intersection B, so you can see that this A intersection B is contained in A. So A intersection B is always subset of A. Every member of intersection is in A and every member of intersection is also in B. So I can write A intersection B is a subset of B. Secondly, if you look at a union, this is a set A, this is a set B, AB. So union is this entire shaded region. So here you can say that the circle of A is contained in A union B. So A is a subset of A union B. I repeat, union means this entire shaded region. This is union. So circle of A is contained in A union B, and the circle of B is contained in A union B. This is always true. So with the help of these two, we have now next property. So now this one is like A is a subset of B. This is a smaller set, this is a bigger set. So if I take the intersection of these two, that is A intersection I'll take the union of these two. If I take union of these two, A union A intersection B, I'm taking union of these two set. One is this, the other one is this. Now this is a bigger set, this is a smaller set. So as per this property, the answer will be A, because this is a bigger set, this is a smaller set for these two. And same way, if I look at this, here I'll take the intersection of these two. So A intersection A union B, I'm using this one, taking intersection. Now this is a bigger set, this is a smaller set. So if I take intersection, so answer will be smaller set. So these are the two important properties which are called absorption laws or properties. What we notice from these two is outside and inside you have different operations: union intersection, intersection union. then the repeated set will be your answer. Outside and inside you have different operations, then repeated set will be your answer. B is there on the left hand side, but it is not there on RHS. That's why it is called absorption. B is there on the left hand side, but it is not on the RHS. For example, you can verify. If I take here n means all integers, intersection, if I take n union all real numbers, then the answer will be n only, because this is a repeated set. Outside and inside you have different operations. Second, if I write q union q intersection r means all real numbers, q means rationals. So if you verify this, the answer will be q only as per these two property. Repeated set is n, outside and inside you have different operations, outside and inside you have different operations. Directly also you can verify here that the answer will be q again. Your answer will be n only. So we have the next important property, this one. Now next one is about identity. If you recall, 1 plus 0 is 1, 2 plus 0 is 2, and so on. So 0 is called identity here. Identity or unit element. So same way here, if I find A union phi, A is any set, phi means nothing, so answer will be obviously A. And if you find A union universal set, now universal set is a bigger set, this is a smaller set, so answer will be bigger set, which is U. If I find A intersection phi, now this is any set A, this is null set, so obviously there will not be any common, so answer will be phi. And A intersection universal set. A intersection universal set. Now this is a bigger set, this is a smaller set, so answer will be A. So here you can say that this is identity element with respect to intersection, and this is identity with respect to union. So for union, identity element, identity is phi, and for intersection, identity is that universal set U, remember, universal set U. So A union phi is A intersection phi is A. Phi means nothing and A means any set, so there will not be any common in this two, so intersection will be phi. Now here for this two you can use this concept, like this is universal set here, this is a set A. Now set is a smaller than the universal set, so if you take the common of these two it will be A only, so A intersection U will be A. And if I combine both the sets, that is A union universal set, it will be U, so this is always true. The next one, that is very important property again, A difference B, which is not equals to B difference A. This is sometimes called only A, this is sometimes called only B, that we know very easily. Now what I'll do is here, I'll draw a Venn diagram. This is universal set U. Here I have set A, here you have set B. First I'll find A dash. So A dash will be this portion. This is A dash. This is A dash. And now next diagram is, I'll show next one, that is Next one I'll show, that is AB here. A dash intersection B. That is, I'll take common in A dash and B. Now you look at this. The shaded portion is A dash. Circle of B is this much. So what's the common in these two? That is this much only. I repeat, the shaded portion is this A dash. The circle of B is this. Now what's the common in these two? That is this portion only. This is the common portion, this much only. That is what I have shown. So what I have shown here, A dash intersection B. So from this, now you recall, what is this shaded portion? It is nothing but just B minus A. So you can say that these two are equal. So your first one is B minus A is always equals to B intersection A dash. And same way, you can see that A minus B is nothing but the A intersection B dash. This is always true, remember. B minus A is B intersection A dash, and A minus B is A intersection B dash.